Let us do some more examples on the integration by parts again. So some of the problems you can apply integration by parts to make it easy to integrate. Some of the problems you will have to use different techniques. Okay, integration by parts is one of the techniques, but some of the problem you can do both by using integration by parts or using the substitution method or any other method. But usually one method is easier than the other if you apply that. Okay, on this example there is 5x over e to the 2x. So if you apply the substitution method, this problem will be harder to do, but if you apply integration by parts, it will be easy. Okay, so how do I write down this one is, you can write 5 is outside, right, and then you can write x times e to the negative 2x dx. You can do like that, right? You can move that to the top and then use integration by parts. You can think this as like u, this as like v, because I'm still using ILATE to consider which one is u. If there is inverse function, u. If there is log function, that should be u. Or if there is a polynomial function, a is algebraic or polynomial function, right? If there is a polynomial function, that should be u. That is the polynomial function, x is u. So just use the formula. Or you can use the table here because there is x, so you can use that, right, directly. So let us try that. So u and then v, right? So u is x, v is e to the negative 2x, right? Do you know what is the formula for the integral of e to the ax? Integral of e to the ax dx is equals to e to the ax over a plus c. Okay, so let us find out the derivative of u. You get x, the derivative of x is 1, and then that is derivative of 1 is 0, right? What is the integral of e to the negative 2x? It is e to the negative 2x over negative 2. That a will be divided there, right? And what is the antiderivative of this guy then? It will be e to the negative 2x over positive 4, right? Because there is already negative 2 and you will have another negative 2 on the denominator, right? Now what we do, you multiply. The first one is the positive multiplication, first with the second one, right? And the second one is the negative multiplication. That curve is for negative sign, and it's stuck because there is 0 afterwards, right? So what do you get then? So you get the integral of, there is a 5 outside, right? And you can do 5x, no problem, okay? Or you can do just 5 outside and then x, no problem. So it is x times e to the negative 2x dx is equals to 5. I'm writing 5. Now the integral of x times that is, what do you get? X times e to the negative 2x over 2. This times that, and then minus 1 times that will be e to the negative 2x over positive 4, right? So that is the final answer. Or if you want to write in the nicer format, then it will be 5/2 x e to the negative 2x minus 5/4 e to the negative 2x. Okay, by the way, it is minus. Yes, that is minus, so that's not plus. So it is oh, by the way, there is negative sign. Yeah, that's what I was talking about. There is negative sign I missed, right? That's the final answer. Or you can use integration by parts, the formula there. Okay, it's exactly the same answer you will get. Since this was easier, I just used that method. Okay, that was question number 16 from the book. Now I'm going to do question number 18 from the book. Let's see how the question number 18 look like. Number 18. Excuse me. So number 18 is, you have integral e to the 1 over t over, there is t square dt. Okay, on this one you can definitely move this to the top, no problem. But think about this, if you move that to the top, which one should be u, which one should be v? Because when you find out the if you take t to the negative 2 as u, but if you find out the derivative of t to the negative 2, it will be t to the negative 3, t to the negative 4, negative 5. It will never goes to 0. So that is not right, right? That is not the right way to do that. Now you can do e to the 1 over t as u, and then t squared, t to the negative 2 as v, but it is still not very easy. But what is the easiest way is u substitution. Set 1 over t equals to u. Now find out the derivative of that. What is the derivative of 1 over t? This is same as t to the negative 1, right? T to the negative 1, the derivative will be negative 1 times t to the negative 2. So it will be negative 1 over t square dt equals to du. Look at that. 1 over t square dt is negative du then, right? So what do you get then? So integral of e to the 1 over t dt over t square can be written as integral of e to the u, right, times negative du. Why? Because e to the u times 1 over t squared dt will be negative du from here, right? So what do you get? Is negative e to the u plus c, because you pull that negative 1 there outside, right? They're negative. And then what is left is e to the u du. What is the integral of e to the u? That is e to the u itself. So what is the final answer then? Negative e to the 1 over t plus c. You see that? Some of the problem, although they are in the product form, it will be easier if you do by substitution method. So you need to you need to think which method is easier, okay? Or if it is applicable, then you can use either of the method, or there may be only one method that makes the problem easier, okay? That was question number 18. Now I'm going to do question number 20 from the book. Question number 20, it has integral of x to the 5 and then times natural log of 3x. Okay, so and then dx. So tell me what should be u? So the formula is I. Is there an inverse function? No. Is there a log function? Yes, there is log. So that should be u. See that should be u. That should be v. Okay, so let us do that. So let us try the table method. So in the table method, this is like u, this is v, right? So it is natural log of 3x, and then this is x to the 5. Look at this. So, and again, so the table method may not work for all the problems, right? So we can try, but if it doesn't work, we will always use the formula. Okay, formula works for all the problems. Okay, but the table method may not work for all the problems. So table method works only if when you find out the derivative of u, it goes to 0. Okay, then table method works, otherwise it does not work. Okay, so what I'm going to do is I'm assuming that u as natural log of 3x and v as x to the 5. Okay, so what you get then is, look at this, find the derivative of that, 1 over 3x times 3, that is the derivative, right? What is the antiderivative of x to the 5? It is x to the 6 over 6. Now, so you cancel that, so you got 1 over x. What is the derivative of 1 over x? Negative 1 over x square. Antiderivative x to the 7 over 42, because you will get 7 over 7, right? Like 7 over x to the 7 over 7 times 6, that is 42. And look at that, there was 1 over x here, right? But see, it does not look like it is going to 0. So this method does not work. So does not work, because the derivative of u is not going to 0. It is going to the 1 over x squared, 1 over x cubed, 1 over x to the 4th, and so on. So it is not terminating. So this method is not good. You see that? That's why I say that this table method may not work for all the problems. Okay, it works only for the certain problems that has x to the n on the first, and then that is u. Okay, if your u is x to the n, then it works, otherwise it does not work. Yeah, okay, that's the best way to say that. If your u is x to the n, then it works, but if your u is the other function, then it does not work. Okay, guys. Alright, so let us do the formula. Let me write down the formula first. The integral of u times v dx, the formula is u integral of v dx, okay? And then minus the big integral, the u prime times integral of v dx, and then there is big ds outside. That is the formula of the product rule. So again, as we mentioned, what is our u? Our u is natural log of 3x. So the formula will be, therefore the integral is equals to, this is u is natural log of 3x times v is x to the 5. So x to the 5 dx minus derivative of u. What is derivative of u? It is natural log of 3x. Derivative will be 1 over 3x times 3 times integral of v. What is the integral of v here? Integral of v is integral of x to the 5 dx, and then there is a big dx outside, right? So you get natural log of 3x, right, times, what is the integral of x to the 5? X to the 6 over 6 minus that 3 and 3 cancel out. We'll get a similar thing there, right? So 1 over x times, what is the integral of x to the 5? It is again x to the 6 over 6 dx. That's what you get. Okay, guys. So what do you get next then? So you get basically, let me write down 1 over 6 times x to the 6 times natural log of 3x. I'm just writing this like little nicer way, minus 1 over 6 times, you see that x to the 6 over 6, that will make x to the 5, but there is an integral sign, integral x to the 5 dx. Okay, so keep working. 1 over 6 x to the 6 times natural log of 3x, right, minus, what do you get? 1 over 6 times, what is the integral of x to the 5? That will be x to the 6 over 6 again, right, plus c. So what is the final answer then? 1 over 6 x to the 6 natural log of 3x minus 1 over 36 x to the 6 plus c. That is the final answer. Okay, so this method always works. This formula method always works. This table method may not work for certain problems. Okay, it works only for the problems if your u is polynomial function. If your u is polynomial function, so that when you find out the derivative of u, it will goes to 0, and then you can use that method. Otherwise, don't use this method. Okay, guys. All right, the next problem I want to do is question number 22. Okay, let us do question number 22. The question is, it has natural log of x. Oh, let me do 22. It is integral of natural log of x over x cubed. Natural log of x over x cubed. Okay, so let us see if we can do like directly u and v, the product rule, or should we do the u substitution first and then change to a certain format? Okay, let us find out that. Okay, guys, so you have basically, I think you can use the table method. That is okay. Let me see that, or you can always use the product formula there, no problem. You can always use that, or if you want to, I think you can use here the table method as well. If there is a table method, what would be, let me write down dx here. Let me write down like little nicer format. It will like natural log of x times x to the -3 dx, right? So what would be u, what would be v? What do you think? So ILATE, there is no inverse, there is log, so this would be u, this would be v, right? So if you use the table method, how that look like? So u and then v, so you will have natural log of x, and then there is natural log of x to the -3. Okay, so one of them will go to a number, right? One of them will go to a number. I don't think it will work, because you see that. So if you find out the derivative, it will be 1 over x, and then -1 over x squared, and so on. So it doesn't go to 0. And if you find out the entire derivative of this, you will get so it will be negative x to the, so it will be x to the -3 plus 1 over -3 plus -1/2 x to the -2, right? And then -1/2 again x to the -1, right? And then so on. So it will never end to 0. Okay, so we don't want to do that method. All right. So what do we want to do then? We want to use the integration by parts. Okay. Let us do integration by parts formula. So this method doesn't work here. All right. So let us do using the integration by parts, that formula. Okay. Which one is u? U is natural log of x and v is x to the negative 3. Let us try that. So here this is equals to u, the formula u is natural log of x and integral of v. What is the integral of x to the negative 3? X to the negative 3 plus 1 over negative 3 plus 1, right? That is negative 1 half times negative 1 half x to the negative 2. That's what you get, right? Minus the big integral sign u prime. What is u prime? 1 over x, right? And then times, what is the integral of v? Integral of v is again, that is integral of v is negative 1 half x to the negative 2, right? Negative 1 half x to the negative 2 and then dx. Are you guys okay? So that will be negative 1 half natural log of x over x squared, right? Negative 1 half natural log of negative 1 half natural log of x over x squared. This is minus times minus is plus, right? And how much is that? X to the negative 2 over x. You can move that x to the top. It will be x to the negative 3, right? X to the negative 3 and then dx. Does that make sense? And then 1 half, I'm pulling this to the front. Now again use that integral formula there. That will be negative 1 half. You can write negative 1 over 2x squared. That is fine. Times natural log of x. No problem. That's the same thing, right? Negative 1 over 2x squared times natural log of x. And then plus 1 half. What do you get? X to the negative 3 plus 1 is negative 2 over negative 3 plus 1 will be negative 2. Because the formula is this, right? X to the n dx will be what? X to the n plus 1 over n plus 1 plus c, right? That's what you get. So that's why you get negative 1 half 1 over 2x squared times the natural log of x. This will again negative 1/4 minus 1/4 and x to the negative 2. You can move this to the denominator and make x squared plus c. That's what you can write. Okay, so don't try this table method here. You can just do that method. The reason why is because we don't have u going to 0. The derivative of u is not going to 0. That's why this method, table method, does not work. But again, as I said, this formula method works for all the problems, but the table method works only for few. But if the table method works, it is a lot easier than the other method, right guys?